Because of increasing digitalization, smooth communication between devices and machines from different manufacturers is becoming more and more important. OPC UA is continuing to establish itself as an open Industry 4.0 standard for this purpose, thanks to numerous properties such as platform independence, scalability, and the option for secure communication. That is why in TIA Portal v14, we've now integrated an OPC UA server directly into the Simatic S7-1500 controller family. This means that you can very easily access data from the controller from any kind of device, like mobile terminal equipment and IT applications. This helps you save time when integrating the S7-1500 into your plant structure. And now I'm going to show you how the whole thing works. I've brought along the setup for this purpose. Of course, it includes an S7-1500 that controls these two V90 drives, which in turn regulate these two axes. With this tablet, I'm going to access the S7-1500 and set one of the axes in motion. This naturally requires an OPC UA client on the tablet, which I've already installed and launched. I find the OPC UA server in the S7-1500 and connect to it. I can browse through the variables, at least those that are made accessible via OPC UA. Here's where I locate the CPU and navigate to the instance data blocks. I find the instance data block for the left axis, and here are the input parameters. I'm mostly interested in enable because I have to switch on the frequency converter and jog forward in order to start the axis. I now modify the values. First, enable. The drive is now ready for operation, and now I start the axis. Likewise, we can also directly connect IT applications to the S7-1500. I'll show you an example of this using Microsoft Excel. For this exercise, I've programmed an OPC UA client in the Microsoft Excel that I'll use to set the other axis into motion. I connect using the Connect button, then I switch on the right-hand drive by clicking Enable. It immediately responds with an acoustic signal. I now start the right-hand axis, and I can play with the speed using the speed control. You can now read out the operating data from the machine, in this example, the operating hours counter. This helps you gain more transparency in your production and your plant. It just takes 3 simple steps to configure OPC UA in the TIA portal. Activate the OPC UA server, confirm the purchase of the corresponding runtime option, then mark individual variables accessible through OPC UA directly in the editors. And now I'm going to show you everything in practice. As you can see, I've already opened the project, and in step 1, I switch over to the hardware properties of the CPU. I can see the CPU here, and I maximize the hardware properties dialog. I find a new entry in the hierarchy OPC UA. Here I can activate the OPC UA server with one click. I still have to confirm the pop-up security note. This informs me that, on one hand, I am opening an additional port for OPC UA, and on the other hand, that in the standard configuration, every OPC UA client is now allowed to access the CPU. I click on OK, and step 1 is complete. Now, for step 2, I switch to the entry for runtime licenses. The TA portal already shows me the license I need, and I simply select the appropriate license. That's all for step 2. For step 3, I switch directly to the editors in order to make variables accessible. First, I open the function block for the axis. Here, I naturally see the program code, which is of less interest to me, and here is the block interface. Here, I'm mainly interested in the columns accessible from HMI OPC UA and writable from HMI OPC UA. They will allow me to precisely specify whether a variable is not accessible at all via OPC UA, if it's read-only, or if it's writable for OPC UA clients. In this example, we can see that static variables are not accessible at all via OPC UA, that the output variables are read-only, and an OPC UA client has read and write access to the input variables. I've shown you how you can very easily configure OPC UA in the TIA portal and then get access to the controller's data from any device. This saves time in integrating the S7-1500 in your plant structure. Now that's efficient engineering in the TIA portal.